Hey guys, so today we'll be working on the Java data structure series. We'll be continuing with we'll be continuing to work on queues. So we'll be using the Java API built-in queues. So the collections package for the built-in classes for the collections are not consistent because they use an interface. So I think it's a queue interface and it's implemented by the linked list. You can check the Oracle docs for that. Just look up linked list and you should see that it implements queue, I believe. So I think there's just a queue interface. There's no actual queue class. That's what I remember reading that. I can just double check here in my old notes. So the Java Collections API is not consistent about its implementation of collections. So I'll be going over this later. I'll be doing some note stuff, theory stuff, so I'll post that after when I have time. But then for the queue interface, so it just says for queues the API provides a queue interface, then various classes such as linked list, such as the linked list class, implement the interface. So the queue interface defines two versions of the methods that add and remove elements from the queue. I think one's called add and one is called offer. Those are for the add methods. And then for the remove methods, one is called remove and one is called pull, and the difference between them is the way they handle exceptional cases. So kind of like in the previous video where I did the dropout stack in the linked stack part 2, I showed you that you can throw an exception if you want, or you can just print out that an exception occurred and return null. So it's up to you. I think that's what they kind of did. Anyways, today we'll be working on the continuation of a encryption. So this code is gonna use queues to encrypt and decrypt messages. So this is an intermediate encryption. This is not just a one where you shift the whole string by one. We're going to actually shift the string by a key. So let's just start coding. So first we're just going to implement java.util. We'll just implement it all. .star. We'll just do a little bit of java doc. Well, first, let's just write the class. Sorry, my mistake. Actually, I'll put that at the top. Public class main. So we're just going to be working out of one class today. We'll do the command line arguments. So here we'll put some Java doc in there. I will say encode and decode a string using a key of values stored in a queue. So here we'll create an int array key. We'll set the array like this. So we'll put some values in there. 5, 12, -3, 8, -9, -4 and 10. Here we'll instantiate an integer variable using the int wrapper class. We'll call this key value. Then we'll say string. We'll create a string variable named encoded. We'll set it like that, and then we'll set one more, decoded. So 2 string variables. Whoops. Honestly, we could just change that. It's I personally don't like it that way. Unless you're trying to really save space, which we don't really need to. Just easier to read like that for me. Personal preference, I guess. It's up to you. So here we'll just create our string message that we're going to encrypt. So we'll just say, again, this is taken from Java Foundations by Lewis. We can, sometimes I change it though, so it's not always the same. But they have a string in here, so we'll just, I'll just use it. I'll use some of it. All programmers are, actually I'll change it, lazy. It has 2 lines, but we'll just use 1 just to keep it easy for now. So here we'll start using our queue, so we'll call the queue interface, I guess. Queue of type integer object. Call it encoding queue. Encoding queue equals, so set equals to new linked list of integer object. That's it. I don't know if we used the linked list. I don't think we did. So this is just the linked list, built-in linked list that Java has. It has its own linked list class. We'll be making a few of those. I think we're making at least 2, maybe 3. It's similar to the stack. It's pretty much the same thing, except you add to the rear instead of the top, or you add to the tail. So same thing. You can also add to the middle or to the front. So here we'll do another queue of type integer object. We'll call it decoding queue. Set equal to new linked list of type integer object. Empty parameters. So here we'll load the queues. For int scan equals to 0. Scan is less than, whoops. Scan is equal to 0, scan is less than key.length, so that's a string, not the array method. So it's using the string method key.length, I believe, and then so that's a for loop. We're starting at character 0. It's the I think it's the same index as an array. Like it starts at 0, goes to less than the length. So every index So if there's 5 characters in your string, like a 5-letter word, or let's just say it's a 4-letter word like tree, if T is index 0, R is index 1, the first E is index 2, and the second E is index 3, so it's not 4, it doesn't go to 4, so that's why it goes to less than 4, which is index 3, so that's why it's like that. Excuse me. So here we'll call encoding queue. We'll call the .add method. I guess pull is implemented in the linked list class. That's okay, we'll just call the add method. We'll add key of index scan. Then we'll call decoding queue .add key of index scan as well. So don't worry about it if you're not seeing the whole picture right now. We'll do a debug. We'll step through the debugger to make sure we understand it. That's the best way to learn. That way you'll see the memory locations. So we'll do another for loop here to encode the message. Nope, it's not fine. 4. I did 4, sorry. Int scan equals to 0. Scan is less than message.length. Oh, sorry, this is a key. So this was an array, my mistake. I was thinking it was a string. I think I was looking at this one. But here's the same idea. It's the same idea exactly. It's just using an array. And here they're using the string method, and that is because you can tell the difference because it's for some reason the string method uses the parentheses and the array method doesn't. So my mistake if I confused anybody on that, and hopefully it clears it up. So for int scan equals 0, scan is less than message dot length. Message dot length. Then length plus plus. Sorry, scan plus plus. So we got for scan equals to 0, scan is key dot length up here. Scan plus plus, encoding queue dot add key of scan, decoding queue dot add key of scan, encode message. For int scan equals to 0, scan is less than message dot length. Scan plus plus, then here we'll say key value equals to encoding queue dot remove. So just change that to a capital. That should fix that, and then we'll say encoding equals to encoding plus, so that's what plus equals says. Sorry, encoded. So plus equals just says encoded equals to encoded plus casted to a char message.car at index scan plus key value. So if you don't know what all these methods are, don't worry. They're pretty easy. They're just all string methods or character methods, so it just tells you what character is at the string location of scan. And scan is going to be our counter for the for loop. So here we'll say encoding queue dot add key value. And that's it. So we have key value equals encoding queue dot remove, or points to, then encoded. So it's a string concatenation in loop. So encoded equals to encoded plus the casted char to message dot char at scan plus the key value. So what's happening here is we're going to take the key value and then we'll say encoded equals to encoded plus message dot char at scan. So it's going to take the it's going to take a letter, like a letter. In our case, it's a letter, and it's going to take like A, and that's going to have some number on the Unicode. I'll try to include that in the description. You're going to have to Google Latin, so Unicode alphabet or something, character index. You should see something from Wikipedia. You're going to have to scroll down to the Latin sub index or something. I don't know why they did it that way, but Unicode is like, they use it like throughout all the languages or something. So every letter like A, B, C, D, E, question mark, $, it all has like a number associated with it. So it's just going to take that number and add the key. So if the key is like 4, then it's going to be like A plus 1 plus 2 plus 3 plus 4, and that's going to go to like B, C, D, E. It's going to go to like E. So that's going to be our encryption. And you can also go negative, so negative moves it to the left, I think. So we'll go through that in a sec. So encoding queue dot add key value, that's it, and then I think we're just going to print it out. Actually, no, we're going to decode it as well. We could have made all these into methods, but that's okay, that's fine. So encode message, can just system out here. Encoded message new line plus encoded plus another new line. And here we'll say decode message. So for int scan equals 0, scan is less than encoded dot length, the string, a method, and then scan plus plus. So for int scan equals 0, scan is less than encoded dot length, scan plus plus. Then we'll just say key value equals decoding queue dot remove. Whoops. Then we'll say decoded plus equals the casted char to encoded dot char at or char at scan minus key value. Then decoding queue dot add key value. And we'll system.print line, then we'll print happened there. So print line decoded message new line plus decoded, and that's it. This is why is it underlining it? Not sure why it's underlining it, but that's okay. Should be fine. We'll just run it to make sure. So just save and run it. Okay, so we got our encoded message and the decoded message. You could change this to take user input, of course. You could write in your own string and it could just change it. You could change these to methods, encode and decode. You could change, so you can make two methods, one for encode, one for decode. You could create getters and setters for all of this stuff. For key value, message, all of these you can create getters and setters, either manually or you could use the IDE to do that. So that's all fine. So we'll just go, we'll create a breakpoint here somewhere. We'll try one here. Some of them won't hit, like this one. It might not get there because it's just not really doing anything that it wants to show or needs to, so it might just start down here. And sometimes that might just actually, yeah, that should be fine. So we'll just start the debugger. You can do that. So right here we're just setting breakpoints. You see those red dots right there? Set one there, and just do it by clicking if you have IntelliJ. It should be the same with VS Code. I don't know Eclipse, sorry, I hate Eclipse. It's really slow. And if we coded this, it would have been still lagging. At least on Windows, because like apparently it's some security thing, but I doubt it. How come these ones don't do that? And the reason why I use this over VS Code is because VS Code uses more memory apparently. I guess it's maybe storing more languages inside and stuff. This is just meant for Java. You can do other stuff in it too. We'll be using PyCharm later, but JetBrains stuff is really good. Anyways, we'll just start debugging, so you just go up to the top right corner, click on that bug thing, debug main, then our thing should come up there. So here you can see our variables and our instance data and stuff. So it says debug main. We have our debugger console. Actually, we don't really have any instance data because we didn't really create any object classes, but So we're just fixing the mic there. So yeah, so that's fine. We're at here. We're at line 15. Are we there? We're here. Okay, we are there. So we'll step into it. Okay, yeah, so it's not going to do anything. So now we're here. So our encoding queue was created. So here we can see it. It's not really letting us click on anything, but it just says linked list at memory location 951, size equals to 0. I guess that's the built-in queue for us using a linked list. So that's polymorphism, I think. So see the previous videos if you're not sure what that is, but here we have our queue class, and we're instantiating in a queue with a linked list. Because linked list is a queue. That's what they're saying, and that's why they're saying in the notes that that's why we were saying that it's a bad example of inheritance, because they're two different data structures. But that's okay. So we're just doing it this way. So then we'll just step through that as well. Step into, sorry. So now we have our other decoding queue. We have our two queues, 951 and 952 memory locations, both are size 0. And then here we'll say for int scan. So here we're at for int scan equals a 0. Scan is less than key.length scan plus plus. So our key is up here. It's an array, and there's 7 digits in it, and we can see that key right there in our debugger console with our variables. Actually, we can't click on it. We can see each index with with its value. So for int scan equals to 0, scan is less than key.length, so the length of the key is 1, 2, 3, 4, 5, 6, 7. Because lengths start at 1, you're not going to say length. You don't count this whole thing as 6. You say it's length 7 of index 0 to 6. So we'll start at scan equals to 0. Scan is less than 7. Yeah, so scan is equal to 0, scan is less than 7, scan plus plus. Step into encoding queue dot add key of index scan. So scan is 0, key is 5. So we're adding to the queue, encoding queue, key of index 0 right here. So 5 should be added to it, to our encoding queue. We'll double check. So now we have encoding queue. We can click on it now. Size 1 and index 0. It says we have our element 5, and we'll be going over the indexes and stuff later, so don't worry. We're just looking at the built-in API right now. So then we're at the next line, decoding queue dot add key of scan. So it's also going to add it to the decoding queue. So decoding queue dot add key of index 0. So it should add 5 there as well. Step into that. Here we go. Decoding queue, same thing. So it's going to do that to the whole thing. So we'll just kind of run through it quickly now. So scan, we were here. Scan was 0. Now we've come back up here to the condition because it's a loop. So it goes like that. Loops back up. So for int scan equals to 1 now, because scan equals to 0, scan less than 7, scan plus plus. So when we get down here, we get back up here. Now it's incremented by 1. So for int scan equals to 1, scan is less than 7, scan plus plus. Step into, you can see scan is 1 now here. Encoding queue dot add key of index 1, so we should add 12 to it, and then 12 to decoding queue. We can see 12 was added. Scan plus plus again, so scan is now 2. Well, not technically till we get there, but I just say it's 2 now. So scan is 2, scan is less than 7, scan plus plus. See, scan is 2 now, we can see it down there. So encoding queue.add key of array scan, index scan, sorry, so encoding queue.add key of array index scan. So scan's now 2, so 0 is 5, sorry, index 0 is 5, index 1 is 12, index 2 is -3, so that's, now we're going to add -3 to encoding queue. Step into, we should see a -3 pop up, we did. Back up here, scan was 2, now we're going to add 1 to scan. Scan is going to be 3. There you go, scan's 3. Encoding queue.add key of array index 3, so 1, 0, 1, 2, 3. So we're going to add 8 to both queues. Step into, we can see 8 was added. Now we come back up here, scan plus plus, so now scan is 4. Encoding queue.add key of array index 4, 0, 1, 0, 1, 2, 3, 4, so we're going to add a -9 to both. So now, came down here, we're back up here. We're going to increment scan by 1, so it's going to be 5 now. Right here, 5. Encoding queue.add key of array index scan, so 0, 1, 2, 3, 4, 5. We're going to add a 4 to both. There you go, 4. Back up here, increment scan by 1, scan's now 6. Encoding queue.add key of array index 6, so 0, 1, 2, 3, 4, 5, 6. So we're going to add 10 to both, and that should be the last one. So we're back up here for in scan equals to 6. Scan is less than key.length, which is 7. Scan plus plus. So if we try to increment scan by 1, scan's going to be equal to 7. So is scan less than, is 7 less than 7? It's not, so that's false, so it should skip down to here, which it did. So now we're going to encode it, so we can close these. I think they updated it. I haven't updated it, but you can remove all watches just to clear it up. I think they changed it now. If you have the updated version, I don't think you can still do that. From there, at least, by right-clicking. If you're using IntelliJ. So scan equals a 0. Scan is less than message.length. So what's our message.length? All programmers are lazy. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, maybe we should have just did one word. Small word. That's okay. We could still change it, but that's fine. So we said 24, I think. So scan equals to 0, scan is less than 24. Yeah, let's just change that, just stop that. And then we'll just change it to like tree, or trees. Just run it to make sure it works. This should be the same, because it's just the key, we haven't changed that. Just our memory locations now will probably be different. So it works. Breakpoints are set, so just hit the debugger. Okay, so we have our Okay, so let's actually just stop that. Take that breakpoint off, take that breakpoint off, and we'll set one right here to encode. That way we don't have to do that again. Okay, so we have our encoding queue. Same thing, different memory location, or it might be the same. At 951, at 952. So for in scan equals to 0, scan is less than message.length, so what's our message.length? Should be 1, 2, 3, 4, 5. So scan equals to 0, scan is less than 5, scan plus plus. Step into it. Usually tells us our message.length. That's okay. So key value points to encoding queue.remove. So it removes from the front, but it should be called it should be called DQ. And this implementation, I think it's removing. It should remove from the front because again queues they go by order, which first in first out, FIFO. So if you add like a 5, 12, -3, 8, like our keys, it's going to take. It should be taking out 5 first. So we'll just see what it is. So key value points to encoding queue.remove. We're in encoding queue, so key value should be set to, there we go, 5. So I believe that's a linked list method. We're just using it as a queue. I guess it removes from the front. So that's fine. So we'll say encoded. Where is encoded? So encoded right now, it's an empty string. So we'll say encoded equals to encoded, which is empty string. So encoded equals to encoded, which is empty string, plus char of message.char at scan. So message and scan is at oh yeah, I'm gonna need the index for this. Sorry. So let me just pull that up real quick. I'm gonna need the Unicode index. I don't have it memorized. Unicode, I should have it somewhere here. Sorry, you won't be able to see that though because it's just a game recorder. Latin alphabet, C, what is that? CO. Control codes, I don't know what that is. ASCII, okay, here it is. That should be what we're using. ASCII, Latin script, Latin alphabet. So it's en.wikipedia.org/wiki/L list underscore of underscore capital U Unicode underscore characters, and then scroll down to Latin script. Then it says ASCII punctuation and symbols, no. Integers, digits, no. Punctuation and symbols, no. Latin alphabet uppercase, did we use uppercase? No, we didn't. So uppercase is actually smaller on the Unicode. Then it has some more punctuation stuff, symbols. Then we have Latin alphabet, lowercase, Latin, sorry, what's the number here? Decimal and octal. Okay, we should be looking at decimal. I think it's decimal. So Latin alphabet lowercase, that's where we're looking. And then so we're gonna have T, it's 116, so 116. So encoded equals to encoded, which is the empty string, plus casted to a car of message, which is trees, dot char at scan, which is 0. So message dot char at, so this is our message, dot character at index scan, which is 0. So T. So it's saying take T and add the key value, which is 5. So T plus 5. So T is 116, so 117, 118, 119, 120. Sorry, 1, 2, 3, 4, 5. So it should change to a Y. So encoded equals to encoded plus car casted to a message. So our message string dot char, so okay, encoded equals to encoded plus char casted to message dot char at scan, which is T. So T plus Y. So encoded equals to encoded plus Y. So the plus here is going to be in concatenation, and the plus here is going to change the Unicode. So encoded should be equal to Y. So we'll just step into. There we go. Encoded was changed to Y. And then encoding queue dot add. So we have encoding queue dot add key value, which is Y. So encoding queue right now, it's gonna remove these numbers and it's gonna add our Y to the queue. There we go. Actually no, sorry. It added 5 key value. Encoding queue dot add. Okay, yeah, so it's adding our key value back to the queue, not the string encoded. Encoded just being saved. We can see it here. What we're doing here is we're taking our key and looping the key over and over again. So it's going to go 5, 12, negative 3, 8, negative 9, 4, 10. Then 5 is going to get dequeued from the queue and added back on, basically enqueued back onto the end. So dequeued from the front of the queue, then it's going to get enqueued to the rear of the queue. So that's how it's going to cycle. Our key is going to be never ending until we run out of stuff, until we need to stop encrypting, basically. Okay, so now we're back up here. For scan equals to, it's going to equal to 1 now. Scan is less than message.length, so scan is less than, what was our message.length? 5, I think. So 1. So scan is equal to 1, scan is less than 5, scan plus plus. So there we go, scan is 1. Key value equals to encoding queue dot remove. So again, it removes from the front of the queue. So our key value should be 12. Then we'll say encoded equals to encoded. So now it's not an empty string, it's Y. So encoded variable equals to our current encoded, which is Y. Concatenate, and then concatenate a casted char to message dot char at scan. So scan's 1, so it's going to be R. Message.char at index 0, which is T, and then 1, which is R. So then we're going to go back to the Unicode alphabet. We'll find R lowercase. It's 114, so 114. And we'll add on the key value 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's a symbol. It's called a tilde. Didn't even know it had a name. TILDE. It's that curly thing beside 1 at the top of your keyboard on the left side. Well, for most keyboards, or at least like English ones, it should it has your numbers going across left to right, and then beside that there's that curly symbol. I think that's what it is. You might have to hold shift for it. So we added 12 to 114. So we should get 126, which is a curly symbol. It's actually the last one on that. I guess if it was more, maybe we would have had to cycle back to the first one. But that's okay. So encoded should be equal to encoded, which is our Y, concatenated to that curly thing. There we go. You can see that curly symbol there. Then we'll say encoding queue.add key value back to the queue, but we're gonna basically enqueue it to the rear now, so 12 is gonna be under 5. So the next one, scan is equal to 2. We'll just do one more. We don't have to do the whole thing, but we'll just do one more. So scan is equal to 1. It was 1, so 1 plus 1 is 2. So now scan is 2 less than 5. So key value is equal to encoding queue.remove. So encoding queue will remove from the front of the queue. We're going to dequeue. I think that's a -3. We have our key value, now it's -3. We'll say encoded equals to encoded, which is that Y and tilde thing. So encoded equals to encoded, our string, casted to. So encoded equals encoded plus casted car or char to message.char at scan. So encoded equals to encoded, which is our string here, plus message, which is our message here, dot char at scan, which is 2, 0, 1, 2, which is E. So we'll take E, look on the Unicode, lowercase e, number 101, then we'll minus. Oh yeah, so that's good. We'll do an example of the subtraction. So we'll add, so plus -3. So plus -3, so the negative and the positive and the negative turn it into a negative. So plus -3 is actually minus -3. So message.char at scan, which is E, 101 minus 3. So 1, 2, 3, it should be a B. We should get a B, so step into. We did get a B. and then we'll add our key back onto the queue. We'll add it to, we'll enqueue it to the rear. There we go. So you get the idea. It's just going to keep doing that. And then decoding, it's going to do the exact same thing. And just instead of adding the keys, it's going to subtract it. So just be careful. Just check the plus and negative if you're going to continue the code. It's already been almost an hour, so just take your, it's the same thing here. It's doing the exact same thing. It's just performing a concatenation. We're doing a casted char, casted to encoded dot char at. So instead of our message string now, it's going to use our encoded string that we have up here. We have three strings. Then we're going to say dot char at, which is exactly the same. Scan, and just instead of plus, we're going to minus the key value, and that way we'll be going backwards. So we'll get the key value that we need to decrypt it. So instead of decode, we can just write decrypt, and here we can write encrypt. So hope that helps, and I'll see you guys in the next video. Take care.